Hello everyone, welcome back to my channel. So in this video we are going to learn about wave equation. Okay, so wave equation, that is mathematical representation of EM waves. Okay, if you are first time to my channel, please consider subscribing and hit the bell icon to get video notifications from my channel. Right, so in the previous video we have got the wave equation, right? Wave equation in terms of electric field. So in terms of electric field we have got the wave equation, so which is given by del square E bar is equal to mu sigma dou E bar by dou t plus mu epsilon dou square E bar by dou t square. Okay, so this is the wave equation in terms of electric field. Okay, suppose if you want to find a wave equation in free space. Okay, so if you want to find wave equation in free space, so what are the conditions for free space? Free space conditions so already I have given you. So sigma is equal to 0, epsilon is equal to epsilon naught, and mu is equal to mu naught. So these are the conditions for any wave propagating in the free space medium. In the free space medium, these are the conditions. So substitute these conditions in the obtained equation, so you'll get the wave equation in free space. That's all, very simple concept, right? So if you substitute these conditions, sigma is equal to 0, so totally this term will becomes 0, right? So leftover term is del square E bar. Okay, so del square E bar is equal to, so mu is equal to mu naught, so mu naught, epsilon is epsilon naught, so mu naught into epsilon naught into dou square E bar by dou t square. So we know that 1 by root of mu naught epsilon naught is c, that is velocity of light, which is 3 into 10 to the power of 8 meter per second. Okay, c 3 into 10 to the power of 8 meter per second. So we have our mu naught epsilon naught, so 1 by c is equal to root of mu naught epsilon naught. So squaring on both sides, it will be 1 by c square is equal to mu naught epsilon naught. So in the place of mu naught epsilon naught, we can substitute with 1 by c square. Okay, so is equal to, so this is the equation, right? So this is the equation in terms of medium parameters. So wave equation in free space. So this is wave equation in free space. In free space in terms of medium parameters. In terms of medium parameters, because mu and epsilon are medium parameters. So in terms of medium parameters, this is the equation for wave in free space. Similarly, so what can we write this? This del square E bar is equal to mu naught epsilon naught can be written as 1 by c square dou square E bar by dou t square. Okay, so this is wave equation in free space, wave equation in free space in terms of velocity of light, in terms of velocity of light. Okay, so this is also one of the equation for EM wave in terms of velocity of light. Okay, so when the wave is traveling, when wave is traveling along plus z direction, right? So positive z direction. Okay, so it will have only z component, right? So it will have only z component. So therefore del square E bar can be written as dou square E bar by dou x square or y square. Okay, so if the component here is x, so it will be dou square e bar x by dou x square, or this can also be written as dou square e y bar. If the component is given is y, so it can be written as dou y square also. Okay, so how can we write this? Dou square, if you want to write in x bar, so dou square ex. Okay, so no need to write this arrow mark. So dou square ex by dou x square. Okay, sorry, this is z square. So wave is propagating in z direction. Sorry, I have done a mistake here. This is dou z square, dou square ex by dou z square. If we have x component, or it can be written as dou square ey by dou z square only. Okay, so you can write any variable. So dou square ex by dou x square or dou z square is equal to, so mu into epsilon, right, for any medium, so mu naught epsilon is for free space. Okay, so for any lossless medium, sigma is equal to 0. So mu epsilon into dou square e x by dou t square, or in terms of y, if you want to write, dou square ey by dou z square is equal to mu epsilon into dou square ey by dou t square. Okay, so this is how you can write the wave equation if the wave is traveling along plus z direction. So you have to remember this concept, this formula. So when wave is traveling along plus z direction, so you have to write like this, the wave equation. Okay, because wave is a function of both space and time. Okay, so it is function of time and it is also function of space. Okay, so next is the del square. This is the wave equation in terms of parameters in free space. This is the wave equation in terms of velocity of light in free space. Okay, so next we'll see generalized wave equation concept. Okay, so generalized wave equation. So what is the general wave equation? Right, so just now we have got dou square ey by, when the wave is traveling along z direction, so dou square ey by dou z square is equal to mu epsilon into dou square ey by dou t square. Okay, so in a uniform plane wave, so if the wave is an uniform plane wave, then E and H are sinusoidal. Yes or no? E and H are sinusoidal, and they are functions of time as well. They are functions of time also. Okay, so that is why we have told in the first lecture of waves that wave is a function of space and time. Okay, so when it is sinusoidal, you can represent this d square ey by dt square in terms of frequency. Okay, so harmonically we can represent this. So how to represent it harmonically? By using differentiation property of Fourier transform. Right, so dou square ey by dou t square. So if you apply the differentiation property of Fourier transform, dou square ey by dou t square can be written as j omega whole square into ey. So this is the differentiation property of Fourier transform. So it can be written as minus j square is 1, sorry, minus 1, j square is minus 1, so minus omega square ey. So dou square ey by dou t square can be replaced with minus omega square ey. So if you replace it, what you will get? Dou square ey by dou z square is equal to, so you will get it as minus, okay, so I am directly writing minus omega square mu epsilon into ey. Right, so let omega square mu epsilon is equal to beta square. Then beta is equal to omega into root of mu epsilon. Beta into root of mu epsilon. Okay, so this is called as phase shift constant. Phase shift constant of EM wave. Right, so this is called as phase shift constant of EM wave. So therefore the equation now becomes dou square Ey by dou z square is equal to minus beta square Ey. So send this term this side, so we'll get dou square Ey by dou z square is equal to plus beta square Ey is equal to 0. So this is second order differential equation. So second order differential equation, so you have to solve for Ey only, because we need generalized equation, right, in terms of electric field. So once you get in terms of electric field, you can easily get in terms of magnetic field, because both are perpendicular to each other. So there are some relationships between electric field and magnetic field in EM wave that we'll discuss in my next classes. Right, so how to solve for Ey? So this is equation, so its characteristic equation is d square plus beta square is equal to 0. So this is the concept from differential equations concept. So d square is equal to minus beta square, so d is equal to plus or minus j beta. So when you have two roots here, one is plus j beta and the other is minus j beta, so how can we write Ey? Ey can be written as some E naught plus into e power minus j beta z plus e naught minus into e power j beta z. Okay, e power j beta z. Right, so when you have two roots m1 like m2, so how can you write the complementary function for this? So it that can be written as some y is equal to c1 into e power m1x plus c2 into e power m2x. Now wave is propagating along z direction, so this will be m1z, m2z. m1 is j beta, right, m1 is minus j beta of course, m2 is plus j beta. So c1 and c2 are constants, that constants we have taken it as amplitudes here. Right, so this is the wave equation in terms of space only. So wave is a function of, so wave is function of space and time. Space and time. So this equation, if you want in terms of space and time, we have to multiply it with complex time function. Okay, so we have to multiply this equation with complex time function, which is e power j omega t, because wave is a function of space and time. So final expression Ey of some z comma t, Ey of z comma t is obtained as e naught plus e power minus j beta z plus e naught minus, right, e power minus j beta z into e power j omega t. So this can be written as e naught plus into, so here it is e power j beta minus j beta z, and here it is e power j omega t. So e power j, if you take common, so it will be omega t minus beta z plus e naught minus into e power j omega t plus, so if this is minus, so this will be plus, no, so e power j beta z, so omega t plus beta z. Okay, so this is the generalized wave equation, Ey of z comma t. So this is the generalized equation. Right, let me write here. So this equation, okay, so this equation e naught plus into e power j into omega t minus beta z, and other equation, other term we have got it as e power j into omega t plus beta z. So this equation is used if the wave is traveling along plus z direction. if the wave is traveling along plus z direction. So understand one by one neatly and perfectly, right? So this equation is used if the wave is traveling along minus z direction. Okay, so this is used when wave is traveling along plus z direction, the first term, and second term is used when wave is traveling along minus z direction. Okay, so this omega t minus beta z, omega t minus beta z is called phase of the wave, is called phase of the wave. Okay, so I'll explain this neatly, right? So how you have to consider the wave, or how you can determine whether the wave is traveling along plus z direction or minus z direction. So in my next slide, in this video only, I'll explain you very clearly, right? So don't worry about that. So just understand the remaining concepts one by one. Okay, so this omega t minus beta z is called phase. We know that it is e power j5 form. So e power j5 form. So this is totally the phase of the wave. Okay, so omega t minus beta z is represents the phase of the wave. So if you equate it to 0, omega t minus beta z is equal to 0. So omega t is equal to beta z, and z by t is equal to omega by beta is called as Vp, that is V suffix p. So this is called as phase velocity. So this is called as phase velocity of the wave. Phase velocity of the wave. Okay, so this is one of the point which you have to remember. So this is very important point, and this is the important formula. So Vp is equal to omega by beta. Okay, so phase velocity is the velocity of the wave at which it travels at this particular frequency, at one frequency, at single frequency. So what is the velocity of the wave is represented by this phase velocity. Understand the term, its formula and its importance. So phase velocity is represented as the velocity with which the wave is traveling at this particular frequency. At a given particular frequency, what is the velocity of the wave is represented by this phase velocity. Okay. Next, if generally if your wave is traveling in a medium, so if wave is traveling, so generally lambda is equal to, we will write it, if the wave is traveling in free space, it is c by f. So if the wave is traveling in a medium, it will be Vp by f. Okay, because the velocity of the wave is now the phase velocity, Vp by f. So what will be Vp? Then Vp is equal to lambda into f. So lambda into f is equal to, so Vp formula is omega by beta. Omega can be written as 2 pi f. 2 pi f by beta. So this f and this f gets cancelled. So lambda is equal to 2 pi by beta, or beta is equal to 2 pi by lambda. So this lambda is called as wavelength. This lambda is called as wavelength. Okay, so this lambda is called as wavelength of this wave, and beta is called as phase shift constant. Beta is always called as phase shift constant, right? So this is the formula for phase velocity. What is phase velocity? The velocity with which the wave travels is called as phase velocity, and lambda is called as the wavelength of the wave. Okay, so these are the different formulas which you have to remember in the case of wave equation. Okay, so let me take one more slide. I'll explain you clearly how to represent the wave when wave is traveling along different directions. Okay, so right, we will see now the representation of waves, or representation of wave equation. Okay, so representation of wave equation when the wave is traveling along different directions. Okay, so if the wave is traveling along plus z direction, suppose wave is traveling along plus z direction. Okay, so if it has x component, right, or if it has y component. So if it has x component, right, so when it has x component, how can we write this? E of z comma t. E of z comma t can be written as E naught x into e power minus alpha z into cos of omega t minus beta z ax cap. Ax cap. Similarly, if it has y component, E of z comma t can be written as E0y into e power minus alpha z into cos of omega t minus beta z into ay cap. Okay, so when the wave is traveling along plus z direction, so these are the wave equations along x component and y component. Okay, so if you observe here, so this is called as, this total term is called as amplitude of the wave. Amplitude of wave. Okay, so this is called as phase of the wave. Phase of the wave. Okay, so in order to make you understand clearly the concept of representation of wave equation, I am explaining you this, even though the video length is more. So have some patience and listen carefully. So this is the amplitude of the wave. So if you observe here, so depending on the different values of alpha, alpha depends on the medium again, the medium in which the wave is traveling. Okay, so we'll see different types of mediums and we'll get different values for alpha. If alpha is equal to 0, then there will be no attenuation. If alpha is equal to 0, then if alpha is equal to 0, this term becomes 1, e power 0. So this total term becomes 1. So the amplitude is constant everywhere. So amplitude is constant everywhere and it is equal to E0x only. Okay, so it is equal to E0x only. So it is same everywhere and it is equal to E0x. Okay, so it is equal to E0x. When alpha is not equal to 0, when alpha is not equal to 0, then there will be attenuation. There will be some attenuation for some medium like good dielectric or good conductor. So good dielectric medium or good conductor medium. Okay, so for such mediums alpha is not equal to 0. When alpha is not equal to 0, then this represents, the amplitude will be E0x into e power minus alpha z. So this represents decreasing exponential. So this, as z increases, this value also increases, so decreasing exponential. So when there is decreasing exponential, amplitude also decreases. So at z is equal to 0, that is at the starting origin it will be maximum and decreases exponentially, that is amplitude gets decreased, which is called as attenuation. Okay, so depending on the medium we will have different values for alpha, and depending on the different values of alpha we will have attenuation, either no attenuation or there will be some attenuation for amplitude of the wave. Right, so from this what we have to learn is amplitude of the wave is not constant in some medium, but in some medium amplitude is constant. So we'll see those mediums and we'll study the characteristics of this. Okay, so omega t minus beta z. So general form is cos of omega t minus beta z. So if it is minus here, so z is there here, so we can say that the wave is traveling in plus z direction. Right, so this is how we can know that wave is traveling in plus z direction. Suppose wave is traveling in minus z direction. Okay, so how will be the formulas for this? E of z comma t is E naught x e power minus alpha z, everything is same, e power minus alpha z into cos of omega t plus beta z. So general form is a minus should be there here. So if you write here minus cos of omega t minus beta of minus z. So plus can be written as minus of minus will become again plus. So wave is traveling in minus z direction. Okay, so this is how we can know the wave is traveling in plus z or minus z direction. Suppose if you have wave is traveling in plus x direction. Okay, so if we have 3 coordinates, right, x, y and z, so we can take wave traveling in any direction of your interest. Okay, so if the wave is traveling along plus x direction, so how will be the equation E of x comma t in this place, right? So it will be suppose you have y component, e o y into e power minus alpha into x, because the direction is now x, right? So cos of, now tell me, omega t minus beta x will come. Beta x will come. So since it is y direction, so you will have ay cap, volt per meter. Okay, so similarly if you want to write in az component, right, so x, when wave is traveling along x direction, so ex and hx are 0, so you will have ey and ez. So suppose if you want to write e in terms of z, so e is 0z into e power minus alpha x cos of omega t minus beta x into az cap, that's all, volt per meter. So only the initial value will change. Okay, suppose if you want to write in minus y direction, so suppose if you want to write the wave equation in minus y direction, so how will write? So e of y comma t is e, so when you y direction, so you can write x and z, so e0x into e power minus alpha y here, because the direction of propagation is along y, cos of omega t plus beta y plus here because the wave is traveling along minus y direction. Okay, so when wave is traveling along minus y direction, you have to take a plus symbol in the middle, so this will be a x cap because it is x component. If you want to write for z component, it is e power e0z e power minus alpha y into cos of omega t plus beta y into az cap, volt per meter. Okay, so this is how we can represent the wave. Okay, so anywhere in the problems, okay, so we will be given with the wave equation like this. So once you are given with the wave equation, you must be in a position to tell the wave is propagating in which direction, what is the value of omega, what is the value of beta, by seeing this the wave equation. Okay, so just remember this formula and the concept, then you can solve any problem in plane waves. Okay.